Standard 16 is the meaning and importance of natural resources. For something to be considered a resource, it must be a component of the earth that human beings value and find useful to maintain and enrich their lives. Some things that were resources in the past may not be resources today or in the future. Some resources may become too depleted to extract or to use them, or better and more appropriate substitutes may be found for them. The three most basic resources that humans need are land, water, and air. Without these three resources, we could not survive. Imagine a world without clean water, clean air, sustainable land, or living oceans. Our natural resources exist in a delicate balance and are vulnerable to changes in the environment. That's why it's important that we all do our part to conserve, preserve, and care for the planet's resources and protect the environment that sustains us with food, fuel, shelter, and medicine. In addition to the three resources just mentioned, land, water, and air, many other materials found on Earth's surface are also valued and utilized by humans. As noted in earlier units, geographers are concerned with the concept of the spatial distribution on the planet. In this slide, we see a map of the United States that shows us where some of the more sustainable, renewable, or perpetual energy sources, such as geothermal, biomass, wind, and solar energy, are located. If you hark back to Standard 15 and the topographical and precipitation maps, you can add this map to your accumulated map information. You will see how, especially the topographical map of the United States, when overlaid with this renewable energy map of the United States, shows a correlation between mountain areas in the U.S. and wind energy potential and geothermal energy potential, which is energy generated from seismic activity in Earth's crust. You can also note that the region of the United States with the most solar energy potential is located in the southwestern portion of the country, here in Arizona. And finally, in the midsection of the United States, around the Mississippi watershed and valley, we see the highest potential for biomass, which is crop residue and organic matter energy. On this slide, you see the same resources as in the previous slide: solar, wind, biomass, and geothermal energy broken apart and mapped separately. Take a closer look. Note once again how the information on these maps correspond with the topographical and precipitation maps that you studied in Standard 15. Natural resources are categorized as perpetual and renewable, or potentially renewable, and non-renewable resources. Perpetual energy is energy that will never run out, like the sun. Renewable, or potentially renewable energies are those that, although they are not perpetual or everlasting resources, if we conserve and use them wisely, are able to be replenished and renewed, and we can continue to rely on them unless we overuse and abuse them, rendering them unable to keep up with human use. In some cases, we can overuse a resource to a point where we have done irreversible damage, and it can no longer be replenished. Trees and vegetative resources, water, and air resources are considered potentially renewable. Non-renewable resources are finite, and once they are depleted, they are gone for human extraction and use. Hence, they are non-renewable. The most common non-renewable energy sources are the fossil fuels: oil, natural gas, and coal. Once they are gone, they are gone. The best example of a perpetual resource is the sun, as mentioned earlier. We enjoy the sun's passive energy every day when we walk outside into the light, or when it shines in our homes during the day. Active solar energy is becoming a greater source for powering our homes and businesses with solar panels that generate electricity. This slide is the same slide that we saw in Standard 15. Solar panels installed at Arizona State University. What a great way to be innovative and environmentally and economically responsible simultaneously. Once again, if you overlay the topographical map you saw from Standard 15 with this map of wind speed, you will see that wind speeds are highest as they blow east off the Rocky Mountains, precisely in the direction where this country experienced the Dust Bowl in the 1930s. Wind serves to facilitate the drying and movement of the soil, and therefore dust production. Although the nation's wind potential is very large, only part of it can be exploited economically. The economic viability of wind power will vary from utility to utility. Important factors to consider with wind potential are production and demand match, both seasonal and daily, transmission of energy to homes or industry or commercial locales, and access constraints, such as public acceptance of wind energy and other technological and institutional constraints. In the bottom left of this slide, we see a wind turbine in a flatland area. Although for the most part, wind is a good, clean, and sometimes abundant resource, it is not distributed evenly across the planet, and to some can be considered an eyesore, and in addition, it is thought to throw birds off their migratory routes north and south seasonally. Biomass is any plant or animal matter used to produce energy. Many plants and plant-derived materials can be used for energy production. The most common is wood. Other sources include food crops, gases, agricultural residues, manure, and methane from landfills. Biomass electrical generation, or biopower, is second only to hydropower as a renewable energy source. Most electricity generated using biomass today is by direct combustion using conventional boilers. These boilers burn waste wood products generated by the agricultural and wood processing industries. When burned, the wood waste produces steam, which is used to spin a turbine. The spinning turbine activates a generator that produces electricity. Many coal-fired power plants also add biomass to their coal burning process to reduce the emissions produced by burning the coal, which is a much dirtier form of energy and also non-renewable. Biomass can also be gasified prior to combustion. Gases generally burn cleaner and more efficiently than solids, which allows for removal of toxic materials. The map in the upper left-hand corner of this slide shows the availability of biomass in the United States. It is clear that most of the potential biomass energy comes from the Midwest and eastern portions of the country. At the bottom of this slide is a graphic of a compost heap. Compost is partially decomposed organic matter. It is dark and easily crumbled and has an earthy aroma. It is created by the biological processes in which soil-inhabiting organisms break down plant tissue. When decomposition is complete, compost has turned to a dark brown powdery material called humus. The process occurring in a compost pile are similar to those that break down organic matter in soil. However, decomposition occurs much more rapidly in the compost heap because the environment can be made ideal for the microbes to do their job. Do you keep a compost heap in your yard? You can put all your vegetable peelings, eggshells, coffee or tea grounds, and other non-meat biodegradable kitchen refuse in your compost heap. And then you can watch it as the decomposers such as bugs, beetles, lizards, and other critters break it down over time into good soil rich in organic matter and plant nutrients. It's a microcosm of activity in your backyard. This slide focuses on hydropower and tidal energy for electricity generation. Energy generated from the action of water and waves and tides can be considered renewable or potentially renewable. But tidal energy and dams have a life cycle and can become non-renewable over time. Tidal energy comes from the gravitational effects of the sun and moon on the seas. The ebb and flow of the tides creates a rise and fall in sea levels twice each day. Electricity comes from tidal energy using barrages or dams, where the tide moves in and out of the bay or inlet, or from tidal streams that drive underwater turbines. Hydroelectricity from dams comes from kinetic energy production when water passes through a dam and spins the turbines, which in turn produce energy. Like wind and solar and biomass and geothermal energies, hydroelectricity is only available in certain places, that is, either in coastal areas or along fast-moving rivers. Like other renewable or potentially renewable energies, hydropower is cleaner and more abundant than fossil fuel or other non-renewable energy sources. A resource is a cultural concept. That is, every culture, through time, has valued different commodities. What is a resource in one place and at a given time varies from place to place and period to period. The value of a particular resource can be economic, or legal, or strategic, or ethical, and even aesthetic and recreational. For example, gold is viewed as a valuable resource. Gold is traded on the stock market and is an alternative to currency, although not one that can be traded in a store. And while gold may have some other uses, most often we think of gold as something to wear on our fingers, or on our ears, or on our arms as bracelets. Gold is a great example of a resource that is important in economic terms and important aesthetically. Cultures worldwide have used gold for millennia as something that expresses beauty and wealth. Another example of a natural resource, although not an energy source, is our system of national parks in the United States. In this case, we value the land that has been set aside by the federal government from development and preserved for us and for the benefit of future generations. With national parks, the value is an ethical one, that the parks and open space should be a part of what all Americans and visitors can enjoy for many years. We also value the parks for aesthetic reasons, for recreation and relaxation, resources that for many Americans are often in short supply. Renewable or potentially renewable resources, such as plants and animals, can be replenished after they have been used if their physical environment has not been destroyed. In this slide we see a cornfield that is used to raise corn that will be used to produce ethanol. We can plant corn for several years in the same field, but eventually that field will become depleted of nutrients because corn takes nitrogen, an essential plant nutrient, from the soil. For a year or two, rotating the crop by planting soybeans, alfalfa, or another leguminous plant will replenish and extend the land's productivity. Trees and forests are another example of a renewable or potentially renewable resource. If trees are harvested carefully and selectively, a new forest can continue to grow and replace the one that is being cut. If animals eat grass in a pasture to a certain level, grass will grow again and provide food for animals in the future, as long as the carrying capacity of the land is not exceeded by the pressure of too many animals depleting the grasses beyond their ability to replenish themselves. Non-renewable resources, such as minerals and fossil fuels, coals, oil, natural gas, can be extracted and used only once. When they are gone, they are gone. These and other non-renewable resources are good examples of resources that may cease to be resources to us if they become too depleted and exist in such small quantities that they are no longer able to be extracted profitably and efficiently. The location of resources influences the distribution of people and their activities on Earth. People live where they can feed and sustain themselves and eke out a living, even if it's only a subsistence living. Human migration and settlement are linked to the availability of resources, ranging from fertile soils and supplies of fresh water to deposits of metals or pools of natural gas. According to the company Nestle Waters, 97.5% of the Earth's water is salt water and therefore not suited for human use. The remaining fresh water is for the most part locked into ice caps and glaciers. This leaves a mere 1% that is actually available for human use and environmental needs. Water is a fragile but renewable resource, and it is consumed primarily by agriculture, followed by the industrial sector and domestic uses. Currently, there is enough water available on the planet for both environmental and human needs. Yet the overall picture must not hide several local difficulties. Water is an unfairly distributed resource, and 60% of all available fresh water is found in only 10 countries. According to the International Water Management Institute, by 2025, as many as 3 billion people will face water shortages. Uneven distribution, growing populations, changing standards of living, changing diets, and urbanization are among the main causes of the predicted water shortages that will result in rising local water stress and constitute the most pressing issue of the century. The water problem can be solved. Providing access to water in sufficient quantity and quality is a responsibility that everyone with a stake in water use shares: agriculture and farming, industry and energy, and domestic users. Population distribution and infrastructure development change and evolve as a resource changes. In previous standards, we saw how some towns in Arizona experienced boom and bust cycles, like the old mining town of Bisbee. During the boom phase, populations rose and towns cropped up in previously unoccupied locations. When the mines were depleted, or the town's reason for being established in the first place was diminished, the town's population declined and many of them turned into ghost towns. Some towns, however, redefined themselves and looked to alternative economies that revived and morphed the old mining towns, or old cowboy towns, giving them new identity and income sources, which once again brought new settlers. A good example of an old cowboy town turned ghost town turned tourist town is Tombstone, Arizona, which was dubbed the town too tough to die. Demand for resources varies spatially. More resources are used by economically developed countries than by developing countries. For example, the United States uses petroleum at a rate that is 5 times the world average. As countries develop economically, their demand for resources increases faster than their population grows. The wealth that accompanies economic development enables people to consume more. However, wealth can also be used to figure out ways to use resources more sustainably so they last longer, especially when we take into consideration that the consumption of a resource does not necessarily occur where the resource is produced or where the largest reserves of the resource are located. In fact, sometimes quite the opposite is true. Most of the petroleum produced in Southwest Asia, for example, is consumed in the United States, Europe, and Japan. Sometimes users of resources feel insecure when they have to depend on other places to supply them with materials that are important to their economy and their standard of living. This feeling of insecurity can become especially strong if two independent countries do not have good political relations, share the same values, or understand each other. In some situations, conflict over resources breaks out into warfare. In this slide, we see three images. The picture of the journal cover, Development, focuses this particular issue on conflicts over natural resources. The picture in the upper right corner shows a scene from Angola, Africa, with a guard standing watch at an illegal diamond mine in the country during its civil war. The cartoon in the bottom right shows how several countries, even countries on the outside of a conflict, may have a strategic interest in the outcome of the conflict and may back one side or another. Conflicts over resources are likely to increase as demand increases for the resources and will potentially escalate when the resource base declines and becomes even scarcer. If we are meant to coexist as a human species, the planet's resources must be managed to guarantee adequate supplies for everyone. That means reserves of renewable resources need to be sustained at a productive level. New reserves of non-renewable resources need to be found and exploited. New applications for flow resources need to be developed, and whenever possible, cost-effective substitutes, especially for non-renewable resources, need to be developed. Therefore, students must understand the different kinds of resources, the distribution of resources on the planet, and the ways in which humans value and use and compete over resources. Also, students should begin to imagine a world in which people can share resources to mitigate potential conflict and suffering. Standard 16 is presented by Elizabeth Larson, School of Geographical Sciences and Urban Planning at Arizona State University, 2011.